Hello, my name is Benjamin Hargis. I'm a PhD student at Tennessee Tech where I'm focusing on robotics. I also have my bachelor's degree in mechanical engineering from Tennessee Tech. I have been an intern at NASA 3 separate times, my first of which was as part of the Aero Academy back in 2016. I'm currently assigned to in-space assembly, and what truly motivates in-space assembly is this concept of modularity. We are currently not capable of launching large structures into space assembled, such as a 30-meter optical bench for a telescope. Therefore, we need to launch the parts individually into space and then assemble them while they are in orbit. I am exploring the concept of inertial transfer. This concept, at its most basic, means passing an object from one manipulator to the next using the object's own inertia. My goals this summer is to create a demonstration using the concepts that we have explored this summer. So my particular contribution to the demonstration is I'm characterizing the surface of our air-bearing table so that our prediction models for the location of the puck will be more precise. The air-bearing table that we're currently using is not flat, not perfectly flat, and so there are certain considerations we have to take into account when passing a puck across the air-bearing surface. So far this summer, my partners and I, Jamie O'Brien and Chase Noren, have accomplished several things, which include the creation and characterization of a launcher, which will simulate an asset in inertial transfer, as well as a pipeline in our software in order to autonomously map the surface of our air-bearing table. Using an accelerometer, I have manually mapped the surface of the table so that we can benefit from having a known map, so that once Chase's program and method becomes fully functional and available, we can seamlessly integrate that into the inertial transfer system. As NASA becomes more interested in reaching the moon and then the follow-on to Mars, we're looking at ways to assemble large structures in space. Having the capability to transport mass without the infrastructure necessary to transport the manipulators and the item at the same time will allow us to benefit from the mass savings, but also task allocation and time, in that once an object is passed from one manipulator to the next, the initial manipulator, so the sending manipulator, can be retasked while the other manipulator waits for the arrival of the package. The importance of the inertial transfer concept lies in its ability to provide a more cost-effective and mass-efficient method of transferring mass in space as we push further into the solar system.